So we're going to look at some static thrust tests of 3-inch props. Now, thrust isn't everything, and static tests aren't a perfect representation of what happens in the air, but it will let us compare the efficiencies and just get a baseline to look at all these props. In future videos, I'll take a look at some live in-air tests. We'll try and do some benchmarks in the air, and also look at acceleration, some of the other kind of non-standard tests that are normally done. Now, I have my own thrust stand that I've designed myself. It is a data logging stand, so we're recording at about 1 kilohertz. The test ramps over about 20 seconds up and then holds at full throttle for 5 or 6 seconds. So we've got a very large volume of data to go over. Now, for the TLDR crowd, don't worry, we'll put the summary right at the top. So if you want, you can jump ahead to, there's only a couple charts that we'll go over. But those thrust charts don't tell the full story, and we'll look at some of the data that we've collected, and there's some interesting conclusions in there. So hang in. It's a bit of a long video, but I hope that you'll get something out of it. Now, really, for the purposes of the benchmark, we don't care so much what the motor is. We just want something powerful enough to spin the props up as fast as possible. But for the purposes of looking at efficiency, I ran all of these tests on a DYS 4000 kV 1306 motor at 3S. It's also powered by a Zeus ESC, 20 amp ESC, running BL Heli 14.4. And here are the props that we're going to be testing. We have the benchmark prop in this class, the Rotor X 3040 triple, the HQ 3030 triple, the Dal prop 3045 triple. This is a Dal TJ 4045. You'll notice that this has the regular tips. It's not a bullnose. Cut down to 3-inch. And then also the Dal 4045 dual blade cut to 3, and this is the Gem Fan 4045 cut to 3. This one is the Gem Fan 3030 bullnose, and this one in particular will notice is very, very flexible. And we will come back to that once we look at the charts. This is going to have an interesting effect. I suspect that we'll see in the thrust. On the Dal prop, we'll notice that the cut, the 4045 cut and the 3045 bullnose, I'm not sure if you can see that, but the blade form is very different between the two of these. And this is, as you could guess by the weight, this is a much thicker blade than this. And that's probably not going to be good for us. In particular, I want to call back on the cut down Dal prop. We cut it down from the TJ 4045, not the bullnose. This is the one with the regular tip, this thin narrow tip again. This is going to be more efficient, and by cutting down from the regular rather than a thicker bullnose, we don't hurt the integrity of the tip as much. Obviously, we are making our own bullnose, and it's not going to have the efficient airform at the end. But by keeping some of the narrowness of the blade, hopefully we'll keep this to be on the more efficient side compared to, even this one, which is very, very bullnosed. And the efficiency of the large, wide props, and we worry about the this one as well. This is not a particularly efficient looking blade form. Here are your basic results. We're looking at thrust in the blue bars and grams per watt efficiency on the orange line. These are not absolute peak values during the test. This is recorded over about a 5-second period of time just after we hit full throttle on the test. So this is a decent indication of an actual sustained thrust that you can get out of the thing, not just spinning up on a purely fresh battery. The Rotor X try comes way out top above all the rest. As you can see, it peaked out at 303 grams of thrust, 2.38 grams per watt efficiency, which is not too bad. Interestingly enough, the cut down Dahl try, the HQ try, and the normal Dahl 3045 try all came out about the same thrust, 289.9, 289.6, 289.4. There's nothing in that, so these basically all perform exactly the same. But you will notice the efficiency is very, very different on these. The cut prop getting 2.38, just about the same as the Rotor X one. The HQ edging it out in efficiency up to 2.5, but the normal Dahl try, very, very low efficiency, 2.1. It may not look like a ton in this chart, but we'll see in some of the later examples. This 2.1 here versus the 2.38, exactly the same thrust, mind. This gives you, like, costs an extra amp per motor at full throttle. So that's not an insignificant loss in efficiency for basically no gain. The cut two-blade props actually fare very well compared to the tri-blades. They're a bit far off the Rotor X, but they're fairly close to each other. 283 on the Gem Fan, 280 on the Dahl. A couple grams between them. It's not really, anything to write home about. 2.85 grams per watt on the Gem Fan, 2.77 on the Dahl. Efficiency is fairly close as well. So we're really only between the dual blades and the tri. We're only losing about 6 grams of thrust, which isn't too much, considering the very large gain in efficiency we get. We're up at 0.4 efficiency to this really horrifically inefficient tri here. Even if we compare it to the more efficient cut Dahl prop, if we look at the cut, the bi-blade Dahl versus the tri-blade Dahl, we're only taking a 2 to 3% reduction in thrust for an 18% reduction in amp draw. That adds up to 1.75 amps less per motor by going with the two-blade over the three-blade. For 2 to 3% less thrust, that's a very large gain. And the poor little Gem Fan 3030 bullnose, down at only 267 grams of thrust, really high efficiency, 2.97, almost 3 grams per watt. But we're losing so much, almost 30 grams of thrust that we're missing out, actually over 30 grams of thrust we're missing out compared to the Rotor X. That's kind of a lot of a drop down to take, and even compared to any of the others, over 12 grams just in this one step. And the efficiency, well, we'll see in a later slide, is not all that it is cracked up to be, just looking at this comparison. So here we're looking at the thrust values of the prop. Now we've taken the motor out of the equation. When you spin a prop at a certain RPM, it makes a certain amount of thrust. So here we're comparing the thrust that the prop makes at a particular RPM. And you'll see these charts don't all go the same distance. That's because as they were loaded differently, the motor only spun them to a certain speed. We can see this number one here is actually the Dahl 3045 Tri. This is that really inefficient prop. You'll see it almost, except for the very, very low at absolute idle, it makes more thrust at the same motor speed than any other prop tested, even the Rotor X Tri, which is the one right below it. But you'll notice that this top RPM that it reached is way lower. We're only hitting about 28.3 thousand RPM way lower than any of these others. So this motor is under a lot of load, and we're going to see that in the efficiency numbers when we look at those. The Rotor X prop gives us a lot more thrust all the way, and you'll see that it ends at a lower RPM because it's at such a heavier load, but our peak thrust, just like you saw in the bar charts, is far and above all of the other peaks for the other propellers. Now, most of this tells basically the same story that we saw on the charts. We've got the our two the Dal cut try and the HQ try, just about the same, and the cut bi-blade props basically overlaying each other too. Again, very, very similar performance through. These two brown lines here at the bottom, these are actually a single test. This is the GemFan 3030 bullnose, and this I believe is just an artifact in my measurement. I suspect that the tack on the thing is an optical tack, and I think perhaps one of the blades had to tape the blade to get it to trigger on the infrared sensor, and so perhaps a bit of tape was there, or the sensor was vibrating a little bit, and so as each blade passed, didn't pass through the sensor in an even cadence. And so we would get two readings, each of these in a slightly different one, as the distance from the triggers are slightly different. So for this one, I'm assuming the actual value is basically dead center between the two of these. But you will notice basically all of these props follow a very similar kind of arc. They curve upwards, and the steepness kind of increases as it goes. But that Dal prop, or the GemFan bullnose, it reads higher or lower down than the others, but it also doesn't curve up quite the same way. This feels a lot more linear throughout there, where you can see several times where it crosses over the curve of the other props. And I think what we might be seeing here is the blade starting to depitch as the motor spins faster, and this is a very kind of wobbly, flexible blade. As it gets under a higher load, the blades can twist against the angle that they're set at and get to a lower pitch. So the faster you spin it, the less pitch it is and the less thrust that it makes. And I don't know for certain, but that's what I would guess that this means, that as we're spinning it up here, like past 30,000 RPM, that the blade is beginning to deform, where all of these other props that have stiffer, thicker blades, they're able to handle the high RPM and the high loads and aren't de-pitching and giving us the performance that we expect. Now this is just a basic look at the efficiency. So this is just a plain chart of the grams per watt over a time period. So this is the very tail end of the ramp up during the prop test, and the switch over to full throttle, and then a long sustained full throttle section. So here, just a plain bigger numbers are better, and we'll see the GemFan bullnose with that 2.9 resting higher above the rest, and that very, very low Dal try being right below them. Same thing that we see on the other one. And you would think, looking at this, well, okay, what if I want something that's going to last a long time in the air, I want the most efficient thing possible, well, okay, maybe I'll choose this GemFan prop, which doesn't make as much power, but the efficiency is better than the rest. But this doesn't tell the full story. So let's go look at the actual efficiency specifically for each one. Now this chart, we're looking at thrust over watts. And what we want here is as much thrust as possible. So we want this to be as high as possible, and we want watts to be as low as possible. The less watts we're using, and more thrust, higher efficiency. And we can see here, of course, right at the bottom, there's that dull 3045 tri, way less efficient. We're getting less thrust per watt. So if we go to 100 watts, we're only getting 245 grams of thrust when we put 100 watts into it, where, I mean, even the bi-blades, 261, and the rest of these were up at 278, 280s. So we're getting not a lot of output compared to the rest. But let's find that GemFan 3030. Here it is, this brown one, and it's not really separated from the pack. You'll notice that efficiency-wise, as we increase the power we put into the motor, it's really kind of right in line, just slightly above the 4045 that we cut down, the tri-blade, and really right on top of that 4045 bi-blade that we cut down as well. So it ends earlier because it doesn't make as much thrust with the lower pitch, and the other one continues up to a much higher thrust value, but the actual efficiency curve is right on top of it. So what this means is there's basically never any reason to get this 3030 bullnose prop, because the efficiency isn't any better than the more aggressive, stiffer blade. If you want to run in this efficient range, get the GemFan 4045, cut it down, and then just put a throttle limiter on, or reduce your maximum microseconds on your ESC, so that if you cut down to 90% of your throttle at this power level, you're getting the same efficiency out of the prop, same power, same efficiency, and you have this extra overhead if you ever decide you need it. You don't lose anything by getting that better prop. Now you can see from the rest of these, you could say, well, why don't I just do that with the tri-blades, get the Rotor X and run it at a lower power? Well, at an equal power level, you'll see that these are actually less efficient. So the Dahl tri that we cut down is kind of on the low side, and that makes sense because we don't have a very clean edge, and the wingtip on the prop tip is just a very straight cut thing, and so that's going to give us some inefficiency there just in itself. The Rotor X one and the HQ tri, or sorry, the HQ and the Rotor X are in very similar range there, basically all throughout here, slightly less efficient than the bi-blade ones just above. But you can also see here actually a very similar thing with the HQ prop. The HQ prop and our Rotor X prop are basically just as efficient as each other, but the Rotor X lets you push into a higher power range than the HQ prop. So if we take our Rotor X prop and then just put a throttle limiter on and don't go into this full throttle range, we can get basically the same efficiency that you get out of the HQ 3030 prop. Amongst all of these, the weight also varies quite significantly. The Rotor X prop is by far the lightest. This is only 1.1 grams, and that's going to have a large effect on the responsiveness of the prop. A heavier prop is going to take longer to spin up and slow down. It has more mass and more momentum. So the lightness of this is going to be a very big benefit. Even the dual blade 3030, this is 1.3 grams. This weighs more than the tri-blade. The cut down duals are 2.5, 2.1. The which one is it? The GemFan. GemFan is 2.1, and the Dahl actually is 1.8. So this is a fairly light prop as well. And if the thrust numbers add up, that would make that a nice choice, especially with the Dahls being fairly resilient to breakage. The cut down triple we're looking at 2.5 grams, so that's fairly heavy, over twice as heavy as the Rotor X, but this does give us a stiffer prop and the dowel material mixture, so this we would hope is going to be fairly resilient as well. The official dowel triple is extremely heavy. This one is 3.3 grams, triple the weight of the Rotor X prop. This is very heavy, and you can tell there's quite a bit of extra material even in the hub. The hub looks like the hub off a 5-inch prop. You've got a bunch of meat both on the top and the bottom of the hub. The blade forms themselves are very thick, so this is a very stiff prop, but that extra weight is not going to be great for us for the responsiveness on what's going on with a small motor. The HQ prop is pretty decent. This is 1.6 grams, so it's heavier than the Rotor X, but it's still a fairly lightweight prop and has a little bit of give to it. I kind of suspect that in flight, I haven't flown any of these myself on my own copters. I suspect they're gonna break a bit, kind of like the old 50-45 bullnose. They tend to kind of crack off, and they're not quite so flexible. That's what I suspect about that. So there you have it. Kind of surprising results, actually. I had done these tests a few months ago, and only managed to put together the summary now. Rotor X prop, king of the roost. Definitely, like, if you're looking for performance, that's the one you want. It's extremely light, so we suspect that when we do response time tests, that's going to come out on top. It feels great on the air. That's most of what I fly. Great power, decent efficiency, but when you're getting those sort of power levels, it's not so bad. It's the real surprise, the tries and the bi-blades, the cut-down bi-blades. That seems like it's not what I expected, even when I had first looked at the results. I've been flying the tries myself for a while now. I'm going to have to give another look to those bi-blades and get them in the air and see how they actually fly compared to what I'm used to. Also, that Gemfan 3030 prop, not good for anything at all. And I didn't mention in the lineup, it's flexible plastic, but it also is really, really brittle, so it shatters like glass and it gets sharp shards, and it's just, you touch it into anything and it goes to pieces. It's really just a terrible prop. The thrust is bad. The efficiency is no worse than the better props, the better two-bladed props up the line. So save your money. They're cheap, but don't bother. Get one of the 4-inch two-bladed props. Cut it down if you're looking for an efficient lower power prop. Give that a shot, and I think you'll be happier for it.